Hello everyone, myself Pawan Bodogala from Annavachar Institute of Technology and Sciences, and I am here to give a presentation on power quality improvement of a proposed single source capacitor based at 13 level boost inverter during off-grid and grid conditions. And my contents of my project is abstract existing systems, drawbacks of existing systems, circuit topology of a proposed 13 level switch capacitor multi-level inverter switching operation, improved nearest level modulation technique, and the simulation model of 13 level switch capacitor multi-level inverter, and specifications of simulation model of 13 level switch capacitor multi-level inverter, and advantages of proposed system, conclusion, references, and future scope. And coming to the abstract of my project, a switched capacitor based 13 level inverter with a lesser number of components is presented in this project. The 13 level single phase AC output voltage is achieved with a voltage gain by including a single DC source. Mm. And my proposed system is having 11 switches, 4 capacitors, and 3 diodes in the proposed converter. The self voltage balancing is achieved for various types of loads without the need of complex control schemes and auxiliary circuit. The proposed topology does not require a back-end H bridge to generate negative polarity. This leads to a reduction in voltage stresses across the switches. The total starting voltage and the overall cost of proposed topology are reduced as compared to the state-of-the-art topology such as a K-type 13 level switch capacitor, multi-level inverter. Mm. And now coming to the existing systems, there are three existing systems are there. 13 level inverter using 15 switches and 3 capacitors. A novel K-type 13 level switch capacitor multi-level inverter topology using 14 switches and 4 capacitors. And the 13 level inverter using 13 switches. Then the drawbacks of the existing system is 13 level inverter using 15 switches, maximum switch stress of the 3 times input voltage. In case of novel K-type 13 level switcher capacitor multi-level inverter voltage gain only 1.5 and total standing voltage is also high. A 13 level inverter using 13 switches with a gain of 6 but maximum switch stress is 6 times the input voltage. This is the circuit topology of proposed 13 level switcher capacitor multi-level inverter. Our proposed system having 11 switches, 4 capacitors and 3 diodes, and the load is connected across the switches. This is the switching operation of our proposed system. The total 14 switching states of operation done by inverter to produce 13 level single phase voltage. At stage 1 and the output voltage obtained as 0 VDC. At stage 2 the capacitor sheet is parallel to the DC source through the switches S1, S3, S4, S11 and diode D1 and charged to VDC. The improved nearest modulation technique. Variable G. Here, the variable G decided factor for switching operation of switches to obtain output waveforms quality, especially its THD and boosting of output voltage. And the modulation is greater than 5 by 6. Here we are using the formula G is equal to 2.5 m. This is the simulation model of 13 level switch capacitor multi-level inverter. These are the specifications of a simulation model 13 level switch capacitor multi-level inverter are mentioned in my proposed system. Voltage and current performance when load changes from R is equal to 50 ohms to 100 ohms. Here the voltage changes and current is constant. This is the output voltage waveform when R changes from 50 ohms to 50 ohms and L is equal to 120 millihenry. This is the 13 level single phase boost voltage waveform. The advantages of proposed system. The proposed topology utilizes only one DC source, 11 switches and 4 capacitors for its operation at a voltage gain. 5 pairs of switches are complementary, thus reducing the number of driver circuits and complexity. TSV is also lowest at 29 compared to the other similar topology. Since the proposed topology is self-balancing, no additional sensor circuits or capacitors voltage balancing methods are required. An improved nearest level modulation technique has been implemented to improve the output quality by minimizing the THD. It also has integrated load ability. These features make it suitable for low voltage source applications such as PV and fuel cells. This is the conclusion of our project. 13 level boost inverter with reduced switch count and self voltage balancing capability of capacitors is proposed. To produce the desired 13 level sextuple single phase AC output voltage, the proposed SEMLI requires one DC source, 4 capacitors, 11 switches, and 3 diodes with a low value of THD, which is 29, and does not require a back-end H bridge. Further, the power quality of the output is improved by including an improved nearest level modulation scheme, which is used for the generation of firing pulses to the switches. The proposed scheme is able to reduce the THD of the output voltage up to 5.08% of the fundamental value of output return. The silent features of the proposed switched capacitor multi-level inverter are highlighted by including a comparative analysis with state-of-art topologies reported in the literature. These are the references for project taken from the given. The future scope of priorities is inverter used in applications such as grid-connected mode as well as renewable energy sources. This topology can be regarded a viable option for low input voltage and high current applications such as in solar, PV, and fuel cell systems. And thank you.